Right, so for blog option 6, write down 2 rules of integration used to solve part A, explaining and demonstrating how the similar integration in part A is found to be -4 using the initial information. Assuming that the definite integral is calculating an area under a curve, the positive function f of x does not have to be a curve, which has the approximate area between x1 and x equals 5 using grid paper. Using a similar sketch, explain how the function 3 times f of x has the area of 12. Right, so the 2 rules I used to solve this equation was this. So basically when you flip b and a, you just put a negative sign before, and when you multiply f by c, you just leave the c right here. Right, so here we have our first equation. We have a positive 12, and here we have a -4. So from 12 to -4, we see how we have multiplied by -1, and we have divided by a factor of 3. Now, how is that? As we can see in this equation, they have just taken out the c, the 3, and now and due to the fact that they have taken out the 3, you have to divide this by 3, which is equal to 4. Secondly, there has been a flip from the b and a values stated in the rule right here. So as a result, when this happens, the value goes from positive to negative. So right here, 12 is positive, 4 must be negative because you're multiplying by -1. And so here we have 2 functions. We have f of x and 3f of x. And we can see that for f of x, we can see the area behind a function is 4. And here we see we are multiplying by a factor of 3, and so the area must be 12, because 1, 2, 3, 4 times 3 columns, 1, 2, 3, 4 times 3 equals 12. Yeah,